0.1 m सोल्यूशन ऑफ एसिटिक एसिड है जो कि 1.35% डिसोसिएटेड है। फ्रीजिंग पॉइंट एंड ऑस्मोटिक प्रेशर ऑफ सोल्यूशन कैलकुलेट करना है अंडर कंडीशंस ऑफ डिसोसिएशन एंड नो डिसोसिएशन। Kf फॉर वाटर गिवन है 1.86। ना परसेंटेज डिसोसिएशन गिवन है, मतलब out of 100 moles of acetic acid 1.35 moles of acetic acid is dissociated. So out of 1 mole of acetic acid 1.35 divided by 100, that is 0.0135 moles of acetic acid will be dissociated. तो ये जो out of 1 mole जो भी dissociation होता है उसको बोलते हैं degree of dissociation. So degree of dissociation of acetic acid is 0.0135. Now depression in freezing point is equal to Kf into m. This is for no dissociation. Kf की वैल्यू है 1.86, m की वैल्यू है 0.1, सो डेल्टा Tf की वैल्यू हो जाएगी 0.186 डिग्री सेंटीग्रेड। दिस इज द डिप्रेशन इन फ्रीजिंग पॉइंट। डिप्रेशन इन फ्रीजिंग पॉइंट का फॉर्मूला होता है फ्रीजिंग पॉइंट ऑफ सॉल्वेंट, प्योर सॉल्वेंट, माइनस फ्रीजिंग पॉइंट ऑफ solution. Now we know the value of depression in freezing point. Solvent is water, so freezing point of pure solvent is 0 degree centigrade. Putting the values and solving, freezing point of the solution will be equal to minus 0.186 degree centigrade. Now to calculate the freezing point of the solution when acetic acid dissociates, then delta Tf will be equal to I into Kf into m. I is want of factor. The value of I in this question is 1.0135, value of Kf is 1.86 and value of m is given as 0.1. Solving, delta Tf is equal to 0.19 degree centigrade and freezing point of solution will be equal to minus 0.19 degree centigrade. Similarly, osmotic pressure of the solution for no dissociation will be equal to N by V, that is number of moles divided by volume of solution into R into T. Now since density of water is 1 kg per liter and molality of the solution is 0.1 m, that means 0.1 moles per kg of the solvent. Now density of water is 1 kg per liter. So if weight of water is 1 kg, then volume of water is 1 liter. Now since the amount of solute present in the solution is very less, volume of solution and volume of solvent can be taken as same. So volume of solution will be equal to 1 liter. Number of moles is 0.1 moles. Putting the values and solving, osmotic pressure is 2.45 atmospheres. Now the osmotic pressure when acetic acid dissociates will be equal to I into N by V into R into T. Here I is the want of factor. The value of want of factor is 1.0135. Number of moles per unit volume is equal to 0.1. Value of R is 0.0821 and temperature is 298 Kelvin. Solving, osmotic pressure is equal to 2.48 atmospheres. Now, how to calculate want of factor? Acetic acid dissociates to give acetate and H plus ions. If initially the number of moles of acetic acid is 1 mole, then when there is no dissociation, the moles of acetate ions is 0 and moles of H plus ions is also 0. Now considering the degree of dissociation as alpha, that is out of 1 mole if alpha moles dissociates, then remaining acetic acid is 1 minus alpha moles and acetate ion formed is alpha moles and H plus ions formed is alpha moles. Total number of moles in the solution after dissociation will be 1 minus alpha plus alpha which is equal to 1 plus alpha. Since the percentage dissociation of acetic acid is given, the value of alpha, that is the degree of dissociation of acetic acid, can be calculated from the percentage dissociation and the value of alpha is equal to 0.0135. So 1 plus 0.0135 gives the value of 1 plus alpha, that is 1.0135. Now the value of I is equal to total number of moles after dissociation, that is 1 plus alpha, and total number of moles before dissociation. Total number of moles before dissociation is 1. So 1 plus alpha divided by 1 is equal to 1 plus alpha. Therefore I is equal to 1 plus alpha, that is 1.0135 divided by 1, and this is equal to 1.0135. Now molality of the solution in this question is given as 0.1 m, which means 0.1 moles per kg of solvent. Therefore weight of water, since the solvent here is water, is 1 kg. Density of water is 1 kg per liter. Therefore volume of water will be equal to mass by density, that is 1 divided by 1, and this is equal to 1 liter. Now since amount of solute present in the solution is very less, the volume of solvent and volume of solution can be taken as same, that is 1 liter, and the molarity of the solution becomes 0.1, that is number of moles, divided by volume of solution in liters, that is 1 liter, and this is equal to 0.1 m. Therefore, while calculating osmotic pressure, the value of N by V can be taken as 0.1, and the osmotic pressure becomes equal to N by V, that is 0.1 into R into T. This is for no dissociation. And when there is dissociation, the value of osmotic pressure will be equal to I into 0.1 into R into T.